So see here, second application of Gauss theorem. We have to calculate field due to a uniformly charged infinite plane sheet. So we take here thin plane sheet of the charge, where the positive charge is distributed here. This is very thin sheet, so this positive charge appears both sides of the sheet. This has got sigma surface charge density, Now, from symmetry, we can take electric field perpendicular to the plane of this sheet, both the sides, and at an equal distance, electric field will be having same magnitude also. So, suppose if you are taking this much part of this sheet, which is enclosed by drawing a cylinder, and this cylinder is piercing into this sheet here. So this whole distance is your 2r. So this side is r and this side is r. At this point we are taking same electric field and perpendicular to the sheet here like this direction, and here it is here this side. So this is here the Gaussian surface drawn here. Now, so we can take one area vector to this side, that is ds1, and another area vector to this side, that is also ds1. And one area vector to the curved surface, that is ds2. And electric field is here every time perpendicular to the sheet here and outward. So now we can calculate total flux. Total flux is equal to vector E dot ds1, this and this, there are both the E dot ds1, so we can take twice, plus vector E dot ds2. We can write twice of E ds1 cos theta plus E ds2 cos theta. Here theta is equal to 90 degrees, so there is no flux through the curved surface of this cylinder. So here theta is equal to 0. So we can write here total flux E dot ds is equal to twice of E, we can take common because E is constant at these points, and integration of the ds1 we can take here this one. Suppose it's the area we take here A, so we can write twice of EA. So total flux through this surface and this surface is equal to twice of E into A. So now total electric flux through the Gaussian surface is this much 2E into A. Now we can write according to Gauss theorem, total flux E dot ds is equal to Q upon A epsilon naught, net charge enclosed in vacuum here, that we can write sigma into A upon epsilon naught. Sigma is the charge density. If you equate these two, you will be getting twice of EA is equal to sigma A upon epsilon naught. This will get cancelled. E is equal to sigma upon twice of epsilon naught. So we can write E vector is equal to sigma upon twice of epsilon naught. Here we can write here n cap. N cap is here perpendicular to the sheet and in outward direction. So this is the electric field here, which is independent of actually the distance here, which basically depends on the charge density. So we have calculated electric field intensity due to thin plane sheet of the charge using Gauss theorem.